Hello everyone, and today we will be seeing one of the problem from LeetCode. It says transformed array. The problem goes like you are given an integer array nums that represents a circular array. Your task is to create a new array result of the same size from these following rules. So for each index I, where I is a valid index, perform the following independent actions. When nums of I is greater than 0, start at index I and move nums of I step on to the right of the circular array. Set result of I to the value of the index where you land. And if nums of I is lesser than 0, then start at index I, move to absolute this value on to the left, and set result of I to the value of the index where you land. And if nums of I is 0, set the current value. Now return the new array we want it to. There is also a note saying since the number is circular, moving past the last element wraps you around to the beginning, and that is true when it is circular. So when we have this example, now it is 3, so jumping 3 points 1, 2 and 3 we get 1, and 1 is the answer stored. So for -2 we have 1 and 2 on to the left, so 1 is the answer over here. Next is 1 on to right, that is this one mentioned here, and 1 in the last. So since it's circular, it will loop back to 3, so 3 it is. So cool. Similarly we have second example as well. So now within this, the thing to notice is that how we are going to move. Like if I have an array like this, so if I have something like this, then in this case obviously we would have 0, 1, these are indices by the way, 2 and 3. So this being index and this being value. Now within this, the problem is when I'm at this position 1, I wanted to go beyond, and beyond would give me 3 plus 1 is 4, which is invalid. And when I'm at position this, I wanted to go backwards, that means 1 minus 2, which would give me -1, which is also invalid. So I have to do some operation where this indices would wrap themselves up. So what I'm doing is taking a mod operation with this number to the length n, and that will give me the appropriate index. So n is nothing but the size, which is 4 here, and this will give me 0. Modding this with n would give me -1, sadly. How can I deal with this part? So if I have a -1, then what I can do over here is add n to it. So if I'm having -1 plus n, and now I'm adding this and I'm taking a mod of n, then this would give me the appropriate position. N is 4, 4 minus 1 is 3, and this will give me 3. So this is how it is proceeded in this way. So we have to get apt index first, then within the result set value at apt index. Apt is nothing but an appropriate index, that's it. So in this case, what I'll do over here is int rs is equal to new int a dot length. What I'll do over here is I'll take out the dot length as n, and this being a, and I'll mark it as final because we are not going to change this part. I'll mark this as final as well, and it will contain n. And remember, we have to return the result. But prior to returning the result, we wanted to iterate for every valid index from 0 till n. Cool. Within this index, what do we have to do? Within this index, as mentioned, we have to get an appropriate index upcoming int apt index, which I mentioned can be taken with the help of mod plus n. So what I'll do over here is I would do I plus n. Again, I have to add this number, right? So a of I, it is I plus a of I plus n mod n. So this will work for a while, and ultimately what I wanted to do over here is set the value. So result of I is equal to a of apt index mod n semicolon. Yes, let me compile this one. This may fail, I believe. Yes, this fails. Why does this fail? So I have a custom test case over there, by the way. So this fails because we don't have index minus 3. Where does this minus 3 comes from? This minus 3 is still over here, where you just consider a value which was within your bounds. So you not only have to take this first, but you have to sanitize this. So I'll take this portion out, is apt index modulo n, but make sure to add n to this apt index first. So apt index is equal to this, and ultimately I'm taking the value from appropriate index. So nothing fancy, just this is the first step, this is the second step, this is the first step, this is the second step. So okay, semicolon missing. Let's compile this. Okay, it has accepted the sample test cases. Let's try to submit this one. Well, it has submitted for rest of all the test cases as well. And the time complexity of this approach is obviously of n with no extra time space complexities, because this space complexity is not auxiliary. With with O of n time complexity, we went ahead. And yeah, this was all about it. And if you like this kind of content, click the video on your right, so that I'll see you in the next one.